So today we're talking about section 5.3, transforming exponential and logarithmic functions. Let's get into it, okay? So if you remember, this A means some kind of stretch, X minus H means moving left or right, and the plus K means moving up or down. Same thing is true over here for the exponential functions. Is A means some kind of stretch, moving left or right, K meaning up or down. This says describe the following translation from the parent graph. State the domain, range, and the equation of the asymptote, then match with the graphs below. Sketch the missing graph. All right, first of all, what we want to do is we want to identify whether each equation is exponential or logarithmic. So for part A, I see that I have an exponential graph because we've got E right there. And now I want to look at what kind of shifts have occurred from the parent graph. So remember that this is growth. A growth function kind of looks something like this. This graph has been shifted 2 units left and 3 units down. Remember, for left or right, the sign is opposite. So this is 2 left and 3 down. Okay. Also, we've got a horizontal asymptote here at y equals -3. That's definitely going to help with the matching, okay? For B, this is an exponential equation as well. We have a reflection occurring here. Over the x-axis. And we see a shift 2 to the left and a shift of 1 up. And we know we're going to have a horizontal asymptote here at y equals 1. Okay, graph C, we notice it's exponential again. I can see a shift of 2 to the right, opposite, remember. And -1 is a shift 1 down. We're going to have a horizontal asymptote here at y equals -1. All right, and now down here, I notice I have a logarithmic function. So let's look at this. We've got a shift of 2 to the left with this log function. And that tells me I'm going to have a vertical asymptote at x equals -2. All right, over here, I can see that I have a log function again with base e. This is going to be a shift down 2 with a vertical asymptote of x equals 0. And F, last but not least, I notice that we have a reflection in the y-axis. Okay, again, it's the log function. I see we've got movement up 2. And again, that vertical asymptote is going to be at x equals 0. All right, you guys, pause this video, take this a second to match the graphs up and sketch the missing graph. All right, so there we go. There's our answers, and we were missing the graph for A, so we went ahead and sketched that, and let's move on. Alrighty, so using what we know about shifting, let's go ahead and get started with some graphing of some functions with some shifting going on. So this is a log function for letter A, and we know that we have a shift 3 to the left, and we have a shift of down 2. I can already tell you that because it's a log function, I'm going to have a vertical asymptote, and I already know x is going to equal -3 for that vertical asymptote. So if we want to go ahead and draw that in, all right, let's go ahead and convert this into an exponential equation so that we can plug some values in. So we can just think of this as y, and we're going to add the 2 over. Y plus 2 equals log base 4 of x plus 3. And we will get 4 to the y plus 2 equals x plus 3. I'm running out of room, so I'm just going to come over here. So let's move that 3 over, and I will get 4 to the y plus 2 minus 3 equals x. All right, so we are going to plug in values for our output and work back for the input. So let's think about some values that are going to be friendly, that are going to work nicely up here with this exponent. So maybe we want to think about -2, maybe -1. 0 might be a little bit too big, but we could do -3. So 4 to the negative first power plus 2 is going to be 4 to the first minus 3, which is 1. So 1, -1 is our first point that we're going to plot. All right, let's do the next one. 4 to the negative second plus 2 is 4 to the 0 power, which is 1. 1 minus 3 is -2. So we've got -2, -2. And 4 to the -3 plus 2 is 4 to the negative first power. That's going to be 1/4 minus 3, which is going to be -2 3/4. So we've got -1, 2 3/4 over, down 1, 2, 3. So we can see this pattern here. Something like this. If you want to do 0, we can. 4 to the second power minus 3 is going to be 16 minus 3, which is 13. So we can see that's going to kind of be off over here. I can tell my domain is from -3 to positive infinity. Those are my x values. And my range is all real numbers, -infinity to -infinity. Okay, so now that we practiced on the first one, why don't you pause this video, go ahead and graph the second one, and when you're ready, unpause to check your answers. All right, let's check and see how you did. I chose some answers that were going to work nicely with my exponent here. Plugged in and got these 3 coordinates. I knew a vertical asymptote was going to be at x equals -7. I could see that here, and I can also see that here. And I went and graphed, and that's what we got. Let's do the last graph. This is an exponential graph, so I don't have to do any adjusting here. I can just plug in a table of values. Since this is a vertical graph, I know I'm going to have a horizontal asymptote at y equals +3 because that's that k value on the end. And I know that my parent graph here has shifted, not left, right 5 and up 3. Let's go draw in the horizontal asymptote at 3. And now let's pick some x values to plug in and get our y values. All right, I'm just looking at my exponent here, and I'm like, all right, I want to deal with things that are easy, like an exponent of 1, an exponent of 2, an exponent, maybe even -1. So I'm going to pick 6, I'm going to pick 5, and I'm going to pick 4. So 6 minus 5 is 1, so I've got e to the first plus 3. That's 2.718 approximately, plus 3, 5.7. So 6 over 1, 2, 3, 4, 5.7 up. Okay. 5 minus 5 is 0, so e to the 0 is 1 plus 3 is 4. So 5 over, we're going 4 up. e to the negative first plus 3 is 3.36. So we've got 4 over up 3.36. And here's what our graph should look like. We've got a domain of all real numbers and a range from 3 to infinity. All right, so let's use what we know to help us find the domain and the range of the following functions. So right here, I know that we have a log function, okay? And based off the log functions, we know that there's a restriction on the domain, but no restriction on the range. So I immediately know the range is going to be negative infinity to positive infinity. And the vertical asymptote is going to be wherever I can set x equal to 0 as undefined. Well, nothing's right there, so that vertical asymptote has to be x equals 0. And since there's no reflection or anything occurring, I know that I have a vertical asymptote at 0, normal behavior, and I know that we're going to be headed from 0 to positive infinity. All right, so the next example, I've got a negative a value in front. Remember from our notes that if we have a positive a value, the function is increasing. And if we have a negative a value, that function is going to be flipped and it's going to now be decreasing because this is a reflection in the x-axis. So we'll be going from increasing like this to now decreasing like this. So that's what that -5 in the front means, is a reflection over that x-axis. But that doesn't necessarily mean that anything crazy is happening to the domain. That might be helpful if we were going to graph this thing, but we just have to talk about the domain and range. I know the range is going to be negative infinity to positive infinity because it's a log function. And really, just to get that domain restriction, I just have to look at what x cannot be. X cannot be 3. So I know I have a vertical asymptote at x equals 3. And since I have a reflection over the x-axis, I know the reflection is occurring, from up here to down here. So I know I'm not worrying about any reflection this direction, which doesn't make me worry about any values over here. I know all the values still exist from the vertical asymptote to positive infinity. So in this case, our function is going to have a domain from 3 to positive infinity. All right, and last but not least, we have another log function. A value in front means it's increasing because it's positive. All right, I have some kind of shift going on here. Let's see at where that's occurring. The range I know is not going to change because it is a logarithmic function. And where the heck is this vertical asymptote? We can just take 2x plus 3 and set it equal to 0 to find out where x cannot equal 0. 2x equals -3 and x equals -3 over 2. Since there's no reflection over the y-axis or anything like that, I know that we're still going to exist from the vertical asymptote to positive infinity. So this graph is going to be existing from -3 over 2 to positive infinity. All right, guys, bye.